Hello everyone and welcome back to Real-Time Systems EEE 4775. Broader module here is context building. Submodule is on real-time programming languages and C. Let's dive right in. So, as you've already seen before, where does this sit topic-wise? We are in the second week here. Embedded System Foundations, broadly harder, chapters 2 and 3. Realistically, first half of chapter 2 is where the discussion on real-time programming languages happens, and also the entire Berry book. We'll go through more advanced topics as the weeks continue, and we'll circle back on memory management that we'll also touch upon in actually the next module towards the end of the semester, time permitting. So, big takeaways here. I want to remind you that this video lecture and many of the video lectures are not rehashes of the book. I expect you, if you are interested and are looking to grow your knowledge, that you're reading the book. These videos are a supplement to that. We'll also take a look, there's a slide on key metrics, key things that you should expect in real-time systems programming. And then we'll focus most of the lecture on how I revisit a language, my approach on how I do this. Perhaps it helps you. Please use YellowDig as well to discuss how you approach learning new languages or revisiting a language. So I want to first start off with the distinction between programmer versus engineer. Think of a technician or programmer as someone who knows how to use a tool or package versus an engineer who knows how that tool or package works. You can understand that if you understand how it works, you can also leverage that tool, that piece of software in a very different way. You understand its limitations, you understand its strengths, you understand when things break, why they're breaking. So, let's take an example here. I understand that the level of depth of how something works is pretty ambiguous. Right, that could be understanding how some piece of software works all the way down to the assembly level, or how that code works on a piece of hardware, what it's actually doing. That level may differ and should differ between different individuals, but the deeper your understanding, the more you might be able to debug and understand the nuances of how something is functioning. Clearly, you can't know everything. The deeper you understand something, it usually means the less you know across the board, right? In terms of your breadth has to be reduced if you're going much deeper. So there's a trade-off here. But again, let's take this at a much higher level where I'm expecting us to be for now. So in application 1 and many of the applications, all of the applications, you'll be using Xtask Create or some version of it. There's a handful of different versions of this. And it takes a handful of parameters. And so the question is, what are these parameters? I would expect a programmer to understand how to use this. And we start there as well in application 1. We explain what these parameters are, and I expect you to be able to replicate this if asked, right? Maybe not for memory, but I'd expect you to now be able to use Xtask Create. And so at the very least, you need to understand what those parameters are. So you have a pointer to a task function. So somewhere in my code, I probably have this blink task function. I better, because that's what's being referenced here. I have a human readable name, which, because I've named things and used some good programming techniques here, I have a human readable name for my function, which is nice. But I also have a string here that represents this task. These do not have to be the same, right? But they are, roughly. We now have next to that a stack depth. We are not sure how that works yet. That's okay. We then have a null pointer, which is a parameter list currently set to null. One priority and a pointer reference back to the task that was created. So those are the actual parameters. Right now, a handful of these are null. Some of these have values. I tell you here, priority 0 equals low. So the higher your priority number, the higher priority this task will have. But okay, that's pretty much it. By the end of this class, though, I would expect that you understand the how and the why behind this function. So beyond just creating a task, how do the parameters influence the system? Do they impact predictability, reliability, the timing constraints that we'll have? How does that all fit together? Those would be the questions we'd expect you as an engineer to be able to answer. So you could learn a whole bunch more. You could go visit the free RTOS documentation area here, learn a whole bunch more about just this one task, right? We'll see more of this no matter what. Let me get us back to a nice presentation view. Not at the beginning, but I guess so. So we'll also see much more in Chapter 4 of Berry. As you look through, you'll see much more about task creation as well. Okay, so what are the characteristics that we expect for real-time programming languages? So we expect that real-time programming languages can handle these 5 things. Data encapsulation. Can we have some way of capturing and holding on to data in a way that is both convenient and also a way that is efficient? Do we have a way to organize data? Do we have essentially mechanisms that allow us to bundle data, iterate over data, work with data, without having to do all the manipulations ourselves? When errors happen, when a sensor value misfires, right? When a sensor for some reason doesn't produce readings that are expected, that are out of bounds, when timing gets violated that it isn't supposed to happen, when there's some conflict that arises that leads to an exception, something that should not have happened but did, can our system handle that without failure? If it can't, then our real-time system is dead in the water, right? So we have to have a way of dealing with exceptions, things that occurred that we didn't expect. Next, synchronization. We have multiple tasks running. Is there a way that we can make sure that they are running in a way that enables them to not corrupt the data that it is interacting with? Is there a way that we can synchronize these tasks, order these tasks in such a way that they are able to accomplish what they need to do without destroying underlying data, without interfering with one another? So can we synchronize? Can we make sure that the tasks are operating in a way that is ultimately leading to a result we want, as opposed to just arbitrarily running without any with any guardrails? Okay, next, concurrency. Is there a way for us to run multiple tasks at the same time? And I use at the same time in quotes because in a single core system, no more than one thing can happen at once. But what we're really talking about here is if I have 4 or 5 tasks that all need to operate in the same time, can we interleave those and make them run together? And then the last one here is message passing. While it is possible for us to have tasks that may not share information or share information between one another, really interesting things, really interesting solutions usually involve moving information between different tasks using messages. So there are other ways to do it, but in general, can I pass a message between different elements within my system? And so those are really the big characteristics that we would expect in a real-time programming language. The book goes into much more depth as well. Okay, so a big question here is, we're going to be using C for this class. You might not be familiar with C. You might not feel like you're an expert in C, but how do you do it? So how can you build up your skills in a new language? I'll give you an example. I started my first internship at Texas Instruments. I walked in knowing C, C++, Java, Visual Basic, Pascal, handful of languages. Day one, I walk in and they say, hey Mike, guess what? You're going to be programming in Perl. Did I know Perl? No, I didn't know Perl. And guess what? It wasn't anybody's job to teach me Perl. So how do you pick up a new language? How do you revisit a language you haven't seen in a while? So here's the flow that I would do today. I would start off by setting up a repository, a code repository, version control, where you can have basically a playground, a history of you exploring the language. It could be as simple as starting off with all of the examples that you see online. You create a new file, new folder, new structure for you to learn and keep track of what you've done. After I have my version control repository set up, I always start off with a hello world. And then my big message is, as I'm learning, I always do the last part, which is I don't just read it or watch it, I do it. You have to engage. And I understand that this can be really daunting, especially if you've already engaged with the language and you've struggled. You might feel not so confident or sure of yourself. I will say dedicate some amount of time, even if it's an hour or 30 minutes a day. Find some way to engage with what you're doing. Don't just try to passively understand it. So, what you could do, start off with version control. I suspect that many of you have not really engaged or used version control too much, but it is a convenient way for you to track the history of what you've done and also be able to recover to known points in time. You could head over and look at skills.github.com. You could go ask generative AI for a learning plan and give you a timeline. Ask it based off of your constraints or off of your situation. Here's what I know. Here's how I'd like to use it. I'm in this class doing these projects. Could you provide me a way to learn the basics about GitHub, whatever tool, in a reasonable amount of time? I don't want to spend more than, pick a time, 15 minutes a day or an hour a week learning. Can you develop a plan for me? So have a couple different prompts. If you come up with something good, post the prompt and also what you found on YellowDig. Let us know what's going on. So then we move into, once you have version control set up, hello world. It doesn't matter if I have done something 1,000 times. I generally still do a hello world with a new environment just in case something has changed, right? It is a great way to have a baseline smoke test of what you're doing. So make sure that everything works as expected. So you should also, you could come up with your own version of Hello World. And what you should be doing is making one that is relevant to what you're doing. The idea is to exercise the components you care about. So down below I have some examples that would work. Looks like an Arduino framework on the right here, and more general C embedded system framework on the left. And they just literally print out Hello World. I'd argue that these potentially don't exercise all the components you care about. Let's see what I mean there. So what does a Hello World look like for our environment? So first off, we are pretty constrained, which is nice. We're using the ESP32. So that is the device and board. Board type is also a good idea to constrain, but for now, let's just consider ESP32. Language framework. So we could be choosing from Arduino, which is a C subset, MicroPython, Rust. We're actually using the ESP-IDF framework, which is also C-based. And why are we doing that? Because we have access to free RTOS. We have a Walkwe simulator, and we also have local editions, Platform IO, that are also in our environment if you've done a local install. Not strictly necessary, but super helpful. So minimum viable environment for us that I would consider ESP32 dev kit, ESP-IDF, Walkwe, right? And that set, especially the ESP-IDF, is also constraining our C choice as well. Local enhancement, Platform IO, well, we won't talk about that too much. So set up your environment and check it. So great time for you if you wanted to pause, go revisit those videos from the first module. There's the 10-minute video for the minimum viable setup that is all online, and then the advanced video for the local install that extends the basic video to get it all working locally. Okay, so consider that you've set up either or both of these environments, the basic one or the advanced one. What is the absolute hello world that we have for a microcontroller? So I argue that it's probably blink something. If you go to the Walkwe interface, you're going to find something different. I believe it does hello Walkwe on the serial port. So what's a realistic hello world? For me, I think maybe it's blink and do something, a transmission on the serial port. So both of those things would be maybe more realistic. Can I blink my LED and can I transmit on the serial port? Those seem pretty standard. Authentic, so where this would really extend is take the I/O that you're expecting, all right, and make sure that it works. So do the GPIO pins, the general purpose I/O pins, do those work as expected? Does the serial connection work? Does Bluetooth work? Does Wi-Fi work? Before you start doing all the nitty-gritty development, you want a baseline to make sure that your subcomponents work in your system. So that's basically what that is. All right, so here's how I would do it. If I was doing Hello World in RSpace, I'd start off with a new project, and I would pick my advanced template, ESP IDF. I would make sure my board type matches roughly what I want. My builder here, so you can basically see here. Here's the ESP32. What it does in the diagram.json is it sets that board type. ESP here, IDF, sets the builder type and the attributes. So it tells basically Walkwe how I think everything's going to get compiled behind the scenes. And then there's some default connections that get set here. The connections here, ESP, transmit, it gets connected to the serial monitor RX, and the ESP's receive gets connected to the serial monitor's transmit, right? So basically those are connected as a twisted pair, as you'd expect. You could ask yourself what happens if you delete this line. So why don't you try that, right? I've told you, instead of just watching, try it. See what happens when you delete this line. Report back if you'd like on YellowDig. All right, so minimum world basic, I'll say, here's the hello world that I would expect in the basic space. You could do as simply as hello Walkwe, right? This I think is actually the default on the left here from what Walkwe provides you in general when you do it. On the right is perhaps closer to what I would do, is I would actually try to see if I could blink the LED and also print hello world or hello Walkwe here. All right, so let's take a little exploration here. The default board only has one LED, unfortunately. So it has one red LED, which you can't actually control, or you're not meant to control. It's a power indicator LED. I think you could probably manipulate it if you really wanted to, but might lead to some unexpected behavior. So same code on the left here, haven't changed that. But let's take a look at how we get an LED hooked up and what it means here when we look at essentially the diagram.json file. So this top part here with the board hasn't changed. We still have the board type, the builder type ESP-IDF, but we now have a new component here, the Walkwe LED. You can see that it's color blue. Here it is on the right-hand side. And then we have some connections here. ESP transmit connected to serial monitor receive, ESP receive connected to serial monitor transmit. But then we have these other connections down here, which happen to be the wires, the black and green wires. So first off, the LED I already pointed out. You can easily change that attribute. LED1 is just the ID name. We'll see how that comes into play in a few moments. But we definitely have an identifier which will help us in defining connections. All right, so we have on the cathode of the LED here, we have LED1:C for cathode. Right, so that's right there. What's it connected to? It is connected to ESP ground. Now there are actually 3 grounds or 4 grounds on this ESP for sure. There's 1, there's 2 at the top, there should be 1 here on the left-hand side, so 3. So 3 grounds, so probably labeled 1, 2, and 3. So ESP ground 3. See what happens if you want to modify the diagram JSON file modify that to a 2 or a 1 and see which one it connects to. The walkway interface should allow it to it'll reroute it. Maybe not nicely, but it will reroute it. Okay, so we continue on. The anode side of the LED, and notice it says LED 1 here, LED 1, LED 1, right? LED anode side, what is that connected to? Well, this is the ESP device, pin 2. There you go, ESP pin 2, pin 2. Why did we choose pin 2? Because in our code, we have connected to LED GPIO, general purpose input output 2. So you'll notice all 3 of those match up. Change any one of these, right? Change this to 4, for example, and see what happens to your code. Does it still work? All right. Before I move on, I do want to highlight one thing. For those electrical engineers in the room, what's missing from this? Anything missing? Or anybody who's done a design before, what's missing from this diagram? Give you a moment to think about it, or look at a previous example. All right. Well, if you thought about it for a few moments, what's missing is a resistor. And so one of the interesting limitations in simulators is it's not actually simulating the physical characteristics of this LED, right? If I pump too much voltage, too much current, ultimately, into this LED, in real life, I'm going to burn out this LED. The simulator won't do that, right? So there are some limitations to simulated environments, namely that there's a chance that if I hook this circuit up in reality, it might not work. All right, so just something to consider. All right, so let me rewind a little bit and remind you, don't just read or watch, do it, right? I just showed you something. Why don't you go ahead and try it? So when we're talking about a language, for me, what are the things that I am trying to do? Well, first of all, I look at any language. Doesn't matter what language we're talking about. There's some key elements, regardless if we're talking about embedded systems or not. There's some key elements to consider. 1, there must be some way to store, retrieve, and manipulate data. Can I do that in my programming language? Do I understand how to store information? Can I get that information back? Can I manipulate it? So storage and retrieval could be locally within the program, right? So that is essentially saving or using variables. Do I understand how to store information using variables or data structures? Can I get information back out of them? Can I manipulate it? Meaning, can I operate on those variables? Can I update those variables? So that's the basics. So start there. So understanding data types, how I store information, get it back, manipulate it, all super important. You could extend that and think about, okay, can I do that to disk? Can I do that can I store it in as a file? Yes, interesting, but realistically start off with the basics of, can I just manipulate data within my program? Next, control structures are huge. Do I understand how the logic works in terms of being able to make a choice? Can I take path A or B? That's critical in almost every programming language, the ability to branch. The next one is looping. How do I iterate? How do I do something over and over again in this programming language? Right? So once I understand data and I understand the basics of the control structures, the next part is, okay, I'm tired of writing a lot of code over and over again. How do I start abstracting and encapsulating things into functions, into ways, reusable formats, reusable functions, data types, structures, whatever it might be? Do I understand the higher level organization or patterns that I have access to make programming more about solving the problem than it is about typing, right? Okay, so then you build up from there. And after you understand the basics of the language, then look at the advanced features. And then my key message again, question and do everything yourself. It's going to be much more beneficial for you to learn and understand if you are constantly asking questions. Why does it work this way? What happens when I try it this other way? What works, what breaks? And yes, it can be daunting and intensive, but if you take it one little step at a time, you're going to gain so much more. All right, so remember, I told you that C has mechanisms. Well, I didn't tell you that it was C, but I told you that our real-time systems should have mechanisms that facilitate 5 things. And so I'm telling you that C should have those mechanisms. So one of the things I'd ask is, could you come up with some minimal examples for how C does 1 through 5 here? And you might come across and you might say, it's not easy to do some of this. And so then you might ask, well, is that why we're using, for example, a framework? Either the FreeRTOS framework or the level of abstraction that's also there is the ESP IDF framework. Those frameworks are going to probably help us with some of these things. But I'll still say, try to see if you could find how to do some of these things in C, or refresh yourself on how to do maybe the basics in C at the very least. All right, so chapter 2 does list 10 areas of interest. All right, and again, I'm going to say question everything. C doesn't have classes, only structures. So the question, is it possible to do generic programming in C? There's a discussion on pass by reference. What does that mean? Can you implement pass by reference in C? Is it possible to emulate object-oriented programming without the encapsulation provided in C? And you could ask some of these questions to ChatGPT. You could do some searching. You could read the book. No matter what, you should try some of these. So again, we keep going through a lot of these. Could go through each one, but I would challenge you, see if you could implement 5 of these concepts. Pick some easy and hard ones on your ESP. See if you could get any of these working, right? Just try, right? Again, you can leverage other tools to help you get started, but see if you can actually get something implemented. A couple of these topics, a couple of these ideas implemented on your ESP. The book might be of incredible help as well here. Okay, so let me give you one quick example of this. So in the introduction of chapter, section, I think 2.24, there's a statement here about the size of different data types. And there was an inconsistency here, right? So I've highlighted it here. Size of float always equals 4, representing 8 bytes. Size of double always equals 8, representing 8 bytes. Well, inconsistency here. 4 and 8, always 8, 8. So slight issue here. What's correct, right? So, okay, I went to Wikipedia to find some information. And what I actually found is that the only requirement in the specification, it concerns the size of integers. And if you look on the right-hand side, there's a table here, float and double. Real floating point type, usually referred to as single precision floating type. Actual properties unspecified, except minimum limits. And actually the exact same thing here in terms of the double. Double floating precision floating point type, actual properties unspecified, except minimum limits. So number one, the always here in these statements isn't correct. And then we still don't really know about the 4 versus 8 bytes. So what would you do? I argue you should do it. Go see what it's like on your system. And you might ask yourself, does it look the same on every system? So I have come up with a really simple example where I look at the size of all of those elements, int, float, double, single node, and then I do some other things down here below for a future memory discussion. But take a look. Let's compile, and it says here, size of int is 4, size of float is 4, size of double is 8, and size of this other data structure that I created is 8. So I created a very quick hello world just to see, and I found my float, my double are definitely different. Let's look back here. So this was the mistake in this particular example here. This one at the top that says 8 bytes should have been 4 bytes. But I will again say, does it depend on the system? Right. All right. You're like, great, thanks for the introduction on languages. What if you specifically need help learning C? So I have a handful of ideas for you, a handful of places to look. I would again ask you to explore. If you have ideas of your own, if you have techniques that have worked for you, share them on Yellow Day with others. So if Here's some quick ones. Freemium sites. So freemium, it's free to use, but they are incentivizing you to pay to probably get advanced features. But SoloLearn, Code Academy are great sites where you can get quite a bit without paying for anything till you get to their advanced features. There's other places like ad-supported sites like learnc.org. Here's a place where you might consider using generative AI as a tutor. I will warn you, be careful how you do this. Remember that generative AI doesn't quote-unquote know anything, right? It has access to a lot of information that it is somehow compressed, and it is retrieving. It can do some searches and things like that and try to reason, but its reasoning is probabilistic in nature. Everything is probabilistic. So perhaps how you could use generative AI as a tutor is to help you determine a learning path, much like you may have done with trying to figure out how to use Git or learn Git. I mentioned earlier, maybe you use generative AI to determine a learning path for you that makes sense based off of the amount of time you can dedicate, maybe based off the programming languages you do know, based off of your prior experience, a couple different ways. But no matter what, don't just read, watch what you see, do it. Don't just copy paste from generative AI and be like, oh, here's my code and it works. Understand it by doing it, right? What happens when you manipulate what you have? Does it work as expected? Can you understand how it works? So my recap is, don't just read it, do it. Question everything, right? Whatever you see, question it, do it yourself, make sure that you believe it. So with that, thanks for watching, and we'll see you in the next video.